Today we're looking at multiplying and dividing by the number 10. I don't know if you've ever noticed, but in our number system, all of the whole numbers go up in a sequence, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then when they get to 10, that 0 through to 9 pattern starts over again. So we get 17, 18, 19, 20, and the pattern starts again, then again, and again. I don't know if you've ever stopped to wonder why we have this system with 10 digits, but I was thinking about it the other day, and I realised that it's because human beings have 10 fingers. And probably when you were first learning maths, you used your fingers quite a bit to help you out, and believe it or not, your fingers and your thumbs are called digits, just like numbers. And we have what's called a decimal system. And the decimal system means that all of our numbers are based around those 10 digits, which match up perfectly with our 10 fingers. So 10 is a really, really important number in our maths system. By the way, the decimal system comes from a Latin word meaning 10, and all of these words which have that DEC prefix at the start have something to do with 10. So for example, a decade means 10 years. Decathlon is 10 sports combined into one. A decagon is a shape with 10 sides. And I don't know if you've ever heard the saying, but sometimes a sporting team is said to be decimated, and that comes from an old battle where the winning general actually ordered that 1 out of every 10 soldiers should be killed as punishment. And from that battle, the story of teams being decimated has arrived. So all these words, decimated, decagon, decathlon, decade, they all come from the Latin word meaning 10. It's a very important number. So let's look at multiplying by 10. And if you've used MAB blocks, you know that when you have a single MAB block and you get 10 of them, you can combine those ones into a long MAB block, which is 10. So you'll notice as well, we've just added a 0 onto the end of the 1 to come up with 10. And the same thing happens if we get 10 of those long blocks, so we're multiplying by 10, then again we can combine them together to make a flat block, which is 100, so a 10 with a 0 on the end. Same thing again, if we get 10 of those flat blocks, we can combine them into a 1000 block. So we've now got 3 zeros on the end of our 1. We've multiplied 1 by 10 3 times, and we've ended up with 1 with 3 zeros. Now probably one of the first times tables that you learnt were your 10 times tables, and it's one of the easiest because you simply add a 0 onto the end. 4 times 10 is 40, 5 times 10 is 50. It's a really, really easy one to learn. And you can see it when you get your calculator. Let's start with a number like 132, multiply it by 10, and it's just put a 0 on the end, 1,320. Times it by 10 again, another 0 appears. Times by 10, another 0. And we can keep hitting the equal sign, and it keeps multiplying by 10, keeps putting zeros on the end, until eventually the calculator can't take it anymore and runs out of space. So let's do a few mental challenges. 12 times 10. You've probably worked out that that's 120, just putting the 0 on the end of the 12. 645 times 10 becomes 6,450. But here's where it gets hard. 1.9 times 10. So it's going to be somewhere between 10 and 20. And the answer is 19. So we don't just add zeros on. This is the interesting thing. Adding zeros on the end of a number is fine as long as it's a whole number, but when we're looking at parts of numbers and decimals, it's a little bit more complicated. Let's look at this one. 2.3 times 10. So what actually happens? Well, when we multiply by 10, this decimal point moves one place to the right. So 2.3, decimal place moves a point to the right, and it becomes 23 point nothing. Now we don't need that point nothing, so that decimal point just disappears, and 2.3 times 10 equals 23. Let's do another one. 1.56 times 10. The decimal point moves a spot to the right, and it becomes 15.6. Let's look now at dividing by 10. Let's start with, say, a 100 block. Dividing by 10 means that we're splitting this up into 10 equal parts. So when we have 100 divided by 10, we're dividing it into 10 blocks, and in this case they are 10 of those long MABs. The way we write this is 100 divided by 10, divided into 10 groups, leaves 10 in each. 100 divided by 10 equals 10. And for those of you who know your times tables, you're going to recognise this as just the reverse of 10 times 10 equals 100. So let's look at it with a calculator. If we have 90, we divide by 10, we get 9. Just the opposite of the times tables that we've already learnt so well. Let's do another one. Let's take a number like 8,000. If we divide by 10, the calculator takes off one of those zeros, and we end up with 800. Divide by 10 again, we get 80. Divide by 10 again, we get 8. The tricky question is, though, what happens when there aren't any zeros to take away? So dividing by 10 is not just about removing zeros. If there are zeros, well, it'll take the zero off the end. But let's look at this one. 845 divided by 10. Well, because division is the opposite of multiplication, we're going to be moving the decimal point to the left. Now, we didn't see that decimal point there because it was a whole number. It is actually there, and we're going 845. Move it one spot to the left, and it becomes 84.5. 845 divided by 10 equals 84.5. Let's do another one. 93.3 divided by 10. We move that decimal point one spot to the left, and 93.3 divided by 10 equals 9.33. So, let's summarise. First of all, multiplication and division are opposites. If you know your 10 times tables, dividing by 10 is pretty easy. Secondly, when you're multiplying by 10, move the decimal point one digit to the right. Secondly, when dividing by 10, move the decimal point one digit to the left. Thanks guys, I hope you found this useful. I'll see you next time.